Hi, my name is Sarah, and I am here to go over the list of all the equations we went over this past week with you guys. To start off, we just need to know that k is the constant in all of these equations, and it's 9 times 10 to the 9th. And r hat is just the vector portion of the equation to make sure that the E force is a vector. So let's start out with a point charge where the force of E is equal k, q of the charge, r hat, over r squared. And r squared is the distance. Like if this was the point charge and there was a little sensor right there like we did in lab, this would be r, distance r. Next we have the line charge. And a line charge would be if this was like a line of charges and there's a little sensor up here. We have to figure out what the force from the electric field would be on that. And to start out with that, the vector of the electric field equals the length of the line times k, lambda is the charge density, over h, this is h root h squared plus L over 2 squared. And we derived this in class. It's just the change if we took a little splice and with the DH, DE, all that fun stuff. And then the next one we need to go over the line. If the line is infinite, then that means there's no length. So an infinite line would be E equals 2k lambda over h. Now, let's talk about a plane. In a plane of charge, an infinite plane of charge is E equals sigma over 2 epsilon.
Everywhere this can take you everywhere you want to go.
That loud. Okay, so E charge, sorry, my roommate turned up the TV. E charge of a plane is this equation right here, where sigma equals charge density in 2 dimensions, which is coulombs per meter squared. Now let's talk about the ring and the disc, and we will be done. So the ring charge, also known as the hoop charge, is, like we discussed in class, this was a ring and it had a charge all over it, etc. And there was a point right here. We're just going to assume this point is on the z-axis. And so this is the radius of the hoop. And this point right here, how far it is, this is going to be r. And this will be the line of the force and theta. And we derived this in class with calculus, but the overall equation then is the E on the line of Z is equal to 2 pi radius k lambda Z, so the length Z. So actually we're going to replace this with Z, over r squared plus Z squared to the 3/2. And if you're confused on how we got that, refer to the lecture notes, but this is something we will need to know for the exam. And then last but not least, a disc. So a disc is just like a ring, but it's an infinite amount of rings, basically. Not an infinite, but a lot of rings in a solid disc. And the same concept applies. This is Z, a point here. And EZ for a disc equals 2 pi k sigma, which is charge density, times 1 minus 1 over root radius squared plus z squared. So if you were given a problem, we'd be given these dimensions and you'd have to plug it in for the E field here. And don't forget to have the vector points, add an r hat there. And those are the main equations that we need to know for this unit.